Hi, welcome. In this video, we will solve problem longest substring without repeating characters asked by companies like Amazon, Microsoft, Facebook, and LinkedIn.
Now let's check out one more problem on sliding window technique, longest substring without repeating characters. Okay, again this is a fundamental problem, quite basic problem on sliding window technique. If you are learning a concepts of sliding window, you should be able to solve this problem. So let's see, given a string s, find the length of the longest substring, the part of the string without repeating any characters. Without repeating characters, that means all the characters should be unique. So let's see, let's check out this example. So we have one string that is a b c a b c b b. So here if I say what will be the small longest substring part of the string that can be possible here without repeating any characters, right? So a, then if I take b, again the characters are unique, so we can again move abc. If I am going again, abca will have one repeating characters a, right? So here abc is the longest substring without repeating any characters, abc. Either you can take this one or this one, right? So abc is the longest part of the substring that can we have without repeating any characters, and that's why the output is 3. Here if I take this is b, right? So what is the longest substring? So this is the only b, right? Okay, so here the output is only b because this is the only unique element, right? Now let's understand how we will solve this problem. So let's take some good edge cases. So let's see, we have D, A, B, A, C, D, and then we have E, D. So if I am taking this string, let me put the indexes 0, 1, 2, 3, 4, 5, 6, 7. Okay, this is my substring. And if I talk about what will be the answer, can you guess it? What will be the answer here? Which is the longest possible substring without repeating any characters? So if you can see, longest possible substring without repeating any characters that we are getting, that is B, A, C, D, E, 5. So that's why the output is 5 as B, A, C, D, E, D. This is the longest possible substring without repeating any characters. Okay, now let's see how we will solve it. What will be our approach? So what will be your first approach? Your basic brute force approach. Okay, always start with brute force approach. So what will be my brute force approach here? If I go on extreme brute force, what I can do? Yes, again. So what we will do? We can generate all possible substrings. Okay, we can generate all possible substrings. Okay, so what will be the all possible substrings here? That will be D, then DA, then DAB, then DABA, then DABAC, and so on, right? Then I will start from A, then AB, then ABA, and then ABAC, and ABACD, and so on, right? Again here, this like it will be a huge. If I take a smaller example of ABC, okay, what will the possible substring? A, then AB, then ABC, similarly, then B, then BC, then C, right? These will be the all substrings possible of 3 characters. So what we will do, now we are generating all possible substrings, right? We will take one of the generated part, like all the parts one by one. Okay, so let's suppose I will take this one first, then this one, then this one, then this one, right? And what I will do, we will pass into a function, like suppose DABAC, this is one substring. I will one pass to a function that will tell me that if all the characters are unique or not, right? So basically what I will do, I will iterate from it. I will say is these running on one time? Yes, A is also one time, B is also one time, but here A is two times, so this is not a possible substring. Okay, and we will take one another case. Let's suppose ABAC. ABAC. Again, I will check. Okay, A is repeating one time, then B is repeating one time. Okay, then A again repeating, so that is not one possible solution. Okay, then I will take again one case. Let's suppose DAB. Okay, so we have D, A, B. Okay, I will check, is D is one time? Yes. Is A is one time? Yes. Is B is one time? Yes. So that is one possible solution. DAB, one possible solution. One possible solution. If this is the possible solution, so what I will do, I will simply store the size of the element, right? So I will store the size of the substring, right? So this will be one brute force approach. Okay, so now let's see what will be the pseudo code of this brute force approach. So basically here in this brute force approach, what I will do, again it's a brute force approach. Okay, so I will simply start from my for loop that will start from 0 and it will run till n. Then I will start from j equals to I, that is also run till n. Okay, and here I will take always new string, right? Suppose temp, you can take temp is a new variable, and here I will add temp plus equals to, suppose my string is s, so I will add s of j. Okay, now this temp, right, I will pass in my function if my check function, right, that will check that it is unique string or not. So I will pass this temp into my check function, and if this is true, so what I will do, we will find the max length. And how we will get the max length, that will be a maximum of your temp dot length and your maximum length. Okay, so this is how, like, I will put it, and this will run, right? And how your check function will be, so basically you will create one check function here. So function check, and that check will take one string. Okay, and you will run a loop that is start from 0 to n. Okay, and you will also create an object because you need to find a unique element. So if that element is defined in the object, like object of str of I, if it is not equals to undefined, that means it is already defined. What I will do, I will simply return false. Okay, that means it is already repeated. And if during this for loop it is not repeating, so I will return true. So this will tell me, this function will tell me if it the given substring is unique or not. What will the time complexity here? So this loop will run for n times, this loop will run for again n times, and we have also one check function, right? And the check function is also running for n times. So the time complexity here will be n into n into n, that will be big O of n cube. Okay, so the time complexity here will be big O of n cube. What about the now space complexity? So in space we are taking an object, right, to find if it is unique or not. So yes, then we will require be the space, and the space will be big O of n. So these will be the time and space complexity. Why space complexity will be big O of n? Because we are creating an object, and suppose if we are able to find all the unique elements, right? All we have unique elements, so the maximum space that we can get, that is big O of n, right? We have all unique elements. Okay, okay. So this will be your brute force approach one. Now let's see how we can optimize it. Okay. So first of all, tell me what are the problems that we are doing here? What were the issues with our code? So first of all, generating all possible substring, is it valid? Do we need it? Why we are generating all possible substrings, right? Can we find out that this character is getting repeated? That means all the characters before it will be repeated. Something like this. Can we find out? So what we will do, we will try some new methods. So let's check out the approach 2 here. Okay, and let's take one string. So let's take the same example. We have d, a, b, a, c, d, and ed. Okay, and let me write the indexes: 0, 1, 2, 3, 4, 5, 6, 7. So now what we will do, we will be requiring one object. So let's create an object. Now what we will do, this is my object. Okay, again the object will be in key value pair. Okay, you can create hash map, whatever it is. Now what we will do, we will use two pointers here. Okay, we will use pointers one by one. So I will take one pointer I here and one pointer j here. Okay, and now let's see how we will use pointer. So now let's closely how we are understanding this, how we are taking the size. Let's suppose right now we don't know the size, right? So my maximum will calculate the maximum size here. Okay, so I will take first element, that is d. Okay, and this can be one of the my length, right? D, that is unique, right? So what I will do, I will first define d and I will define with it index. Okay, I will define with the index, right? So I will write the index. So d with a value of 0. Okay, and now what is the size of, if I say that this is my substring, d is my only the substring, what will be the size? How we will calculate the size? So again, size will be calculated here by I minus j plus 1, right? So I is at 0, j is at 0, 0 minus 0 plus 1, that is 1, right? Only we have one element. Now what we will do, again, right, there is no any issue, single element, right? We have put it indexes. Remember here is the element and here we are putting the indexes. There will be some magic why we are putting indexes. Okay, we will get to know. So let's change my pen and let's use green then. So what I will do, I will move my I pointer here. I will take the next character, that is a. Okay, and what is the indexes? That is 1, right? So a with an index value of 1. Okay, I will mention a here as well. And what will be my size now? Size will be 2, right? So can I say now my size will be 2? Okay, and my maximum is also updating, right? It will be 2. Again, no issues, we will move ahead. We'll go to b and I will mention b with the index value 2. Okay, now b is also there in my list and my size will be 3 and my maximum is also 3. Now what we will do, we'll check the next element and we got e, right? But e is already defined, right? E is already defined. So that means if I am taking this character, that is a repetition. This character is a repetition, right? We can't take it. We can't take it. This is a repetition. So what I will do, I will find the first occurrence of this a. And how I get to know that first occurrence? I have stored it here, right? When this a occurred first time, that is with the index value of 1. So what I will do, I will simply surpass this j. So I know that this is the value, this is the index, right? A is here. So what I will do, I will just take the next element because I already know that this is A is repeating. So why should I start from A, right? I should not start from A, not never should start from A. So what I will do, I will find the index, that is 1, and I will move my j pointer to A plus 1, right? The next element, my j pointer will be here. Okay, that means I will start from taking character from B. I will simply leave it because I already know my I pointer told me that A is already defined. Okay, and I will store the new A index. What is the new index? A index, that is 3. Okay, and now what will be my I minus j plus 1? So I is at 3, j is at 2, 3 minus 2 plus 1, that will be 2. Okay, but again my maximum was 3. And what was this? DAB. This was my maximum, right? So now we are starting from B, right? Now you can see if I am taking this string, that is B, BA. I directly got this size of the string. So what is size 2? BA is the size 2. Okay. Now again what I will do, I will move my I pointer. C is unique. Yes, C is unique. What is the index? 4. Okay. And once I mention it, so what will be my I minus j plus 1? That will be 3. Okay. Maximum is already 3, so no need to update. Then again my I pointer will move. Okay. I got D. D is unique. Yes, D is unique. I will define with D with an index 5. Okay. And what will be my new size? That will be 4. BACD. And my max will also be updated. Okay. This will be BACD. Max will also be 4. Again, I will find new element. Okay. That is E. Then index value of 6. Okay. No worries. I will simply move it. I will move it. And what will be my new size? Again, I minus j plus 1. So that will be 5. And my max will also be updated with 5. Now I have next element. Okay, that is D. Is D is already defined? Yes, D is already defined. So now what I will do, okay, I will say that I will find that which is my new element. Okay, D is already defined. When my D first introduced, so it is introduced here at the fifth index, right? So what I will do, I will say my J that start from here just after the D, because till here I can say all these things will be repeated, right? If they are taking, all the things will be repeated. If it will start from E and D, right? E will be the new element, then D will be the new element. Okay, so again like here I will start from ED. My J will be updated, right? So size now will be 7 minus J is at 6, 7 minus 6 plus 1, that will be 2. New substring will be now E and D. Okay, but your maximum is still 5. Again you will move I pointer, and that's the limit. So the maximum you got, that is 5 here, right? So this is how it works. Okay, this is how this work. Let's take one more example to understand. Let's now take a short example here. Okay, and let's suppose you have one string as D V D F. Okay, so what is the maximum length here? Can you tell me? With non-repeating characters, that is VDF. Okay, so the answer is 3 VDF. Okay, so now let me quickly put the indexes 0 1 2 3 key value pair, and let's start. So we have one I pointer, we have one J pointer, and we will calculate the size with I minus J plus 1, and we will calculate the maximum. Okay, so now let's see. So I got D first. I got D. I will simply define D with a value of, with the index value of 0. No worries, everything is going fine. Then I got V. I will define V with an index value of 1. Okay, okay. What is the size we got right now? 2. Maximum is also updated to 2. Now you got again D, right? Again D. So what I will do, I will find the first occurrence of D. Where is my first occurrence? This is the first occurrence of D, right? And I will say my J to simply move just after it. I will take from here. So if I'm moving from here, what will be my I minus J plus 1? I is at 2, J is at 1, 2 minus 1 plus 1, that will be 2. Max is also 2. So now we are not taking dv, we are taking vd. Okay, now again I pointer will move. I got f with a frequency of 3. Okay, and when c we got d also, so we update the frequency of d as well, so it will be 2 now. Okay, now so we got f within 3 value, so I will add it, and I will say I minus j plus 1, that will be 3. Maximum will also be uploaded to 3. Okay, and then I that's the limit of the question, and you got the maximum answer as 3, right? So this is how we will apply this approach. This will be my approach, and basically we will find the first occurrence of the character, right? So if like any time like here we are getting first occurrence of A is here, so we will just take the next of it. Okay, we will start from B, A, C, D. So now let's see what will the code of this approach, right? So I will take one J pointer equals to 0, then I will create an object, or you can say hash map. Okay, I will take one size variable, the minimum size can be 0, and I will start a loop. Okay, that will start from 0 to s dot length. Okay, okay. So my first goal will be like I will simply define so s of I, right? If it is not present, I will simply define with its index value I will define it, and I will calculate always size. How to calculate the size? Basically I will find the max of I minus j plus 1 and my size. Okay, now here is the condition. What I will do, I will say if it is already defined, right? If it is already defined, how I get to know that if it is already defined, that s of I is not equals to undefined. It means it is already defined. Okay, so what I will do, I will simply say j equals to object of s of I, whatever the s of I, plus 1. Move the pointer to the plus 1, and here like here we will also take care that my j pointer, this will only one work when my j pointer is less than the object of s of I. Okay, so whatever the position you are telling to j should always be less than, right? So what is my meaning of it? So suppose in this case d a b a c d e f, right? If your j is somewhere here, okay, okay, and you are getting an object of index of this a, right, or b, will that work? No, because your size is I minus j plus 1, right? You will take this much distance, this much element, right? So your j should always be less than the object index, right? The value of index. Okay, so yeah, this will be the code of it, and now let's quickly check the dry run. No, like the time taken by the code. So this will run for n times, and here what we are doing, we are simply just checking is it undefined or not, and we are simply finding. So this will run only n times, so the time complexity of this approach will be big O of n, right? What about the space complexity? So again you are defining in the object with the index value. So again if all the elements are unique, okay, and we have the longest substring without repeating any characters, so the space complexity will be big O of n. It depends on the size of the string, right? So space complexity is big O of n, time complexity is big O of n. Now let's see how we will implement this approach. Okay, so in the next video we will see the code implementation of it.